In this video, I am going to explain STAR project data. Basically, it was 4-year studies carried out in Tennessee, and there were 3 class sizes: regular class size of 22 to 25, regular class plus 8, small class size 13 to 17 students, and it was basically an experiment to study whether there is an improvement in learning achievements of students. So regular class size, basically with aid and without aid, were re-randomized at grade 1. So children were taken at kindergarten level, KG level, and they were studied for 4 years. There were 80 schools which participated, and roughly 12,000 students participated in this. You can read more details from Stock and Watson, section 13, section 4 from chapter 13, and each year there was a standard test, Stanford Achievement Test score. We'll also carry out this in Stata as well as in R in our next videos. So there was 10% students who switched, partial compliance. But if these switched due to some behavioral problems or due to some other adjustment problems, and it means they were random, so it will not make much difference in your results, because that was basically there was no until and unless parent forced that our children should go to a small class size, or some other reason. If it was random, partial compliance, 10% students basically switched due to incompatibility and behavioral problems. So in general, it will not affect the results of experiment, should not affect the results of experiment. Attrition, as many students may have moved out of districts and some have moved into those, and there may be some little bit attrition effect as well. So basically what is going on, you see we have 3 class size, so therefore we have introduced 2 dummies, 2 binaries, small class size, regular, aid. So your regular class size is your reference category. So what do we say? Beta 1 is basically an improvement as compared to regular. Regular with aid is an improvement with reference to regular. So there can be additional regressors which we'll talk later on. Teachers' experience, free lunch eligibility, gender, race, and all that. So what is basically now the results? What are the results? So we have calculated differences estimators. So you see, on average, kindergarten students scored 13 points, 14 points more than regular class, and regular class with aid basically at KG level has not much improvement as compared to regular class. At grade 1, when they were re-randomized, again 30 points test score difference between small class size and with reference to regular class size. Regular class size with aid also is significant here, and it has 12 units improvement. At grade level 2, in the 3rd year, you have 19 points improvement, and here again it is not significant and not much improvement as compared to regular class. So here again small class size 16 points better score than regular class, but regular class with an aid has actually no effect. So what do we see? That in general, small class size leads to improvement in test score. But what has been pointed out, that in general this difference of around 14 points basically remains same over time. It does not improve. If it was initially there of 14 points, it remains more or less 14 points, 16 points. So over time it does not improve as compared to regular class size. It does not change much as compared to regular class size. Now you see there can be many other potential omitted variables. If we include those omitted variables, whether what is the gender, what is teacher's experience, whether there is free lunch availability, black, race with white, race other than black or white, and whether you have basically fixed effect models taken into account or not. So you see the first model is the same, for this is for kg, this is only for kg. We are now considering these factors. So in general, 14 points, 14 points, 16 points, 16 points. In general, this effect remains more or less same as we have seen without including these additional regressors. Here you have basically boy and all that, but my variable of interest is this one, so I am not going to comment a lot on this one. You may have teachers' experience which matters and fixed effects. So in general, there was a difference of around 15 points, 16 points when you take small class size as compared to regular class size, and regular class size with aid has actually not much difference, So now this is basically not in standard units. If you take it in standard units, how do we take it in standard units? That is, we basically standardize these variables. Then what will be the results? Basically, if you want to compare these results, as I have discussed in many of my videos on California test score data and in chapter 9 and Massachusetts data, if you want to compare these results with those results, then you must have these variables in standard units. To standardize the variables, you have basically, after standardizing the variables, you see that kindergarten has an improvement of 0.19 standard units with plus minus 3 standard error as compared to kindergarten, and as compared to regular class size, and this has no difference. This is same as we have already studied, no difference, and here you have 0.21. So in standard units, this difference is not statistically significant, but may not be very large. When we compare it with the California and Massachusetts observational studies, what happens that in general we see that California and Massachusetts studies, basically the results chapter 4 to chapter 9, basically your star project data standard deviation, that is means your standard unit scores remain somewhere between 0.13 and 0.22. California standard unit test score as compared to large class size and small class size are 0.04 to 0.24, and Massachusetts also is between 0.02 to 0.22. So in general, what do we see here? That experimental results from these experiments are very much similar to results from observational studies. So regression is a very useful tool when you basically study this with the when you have good design, correct functional form, and you take care of external internal validity threats. So, there can be other factors which may affect your results. So you can look at these factors and you can improve your results. Control variables, you can have percentage English learners, lunch percent. Please be careful. Here coefficient of lunch percent is minus 0.547. Does it mean that if we provide lunch, there will be low test score? That's very naive conclusion, because before jumping to such results, please note down my variable of interest is this one. I have ensured that class size is independent of UI. I am not sure that whether lunch percentage is also independent of UI or not. So causal interpretation should be restricted to what is your variable of interest. So therefore, please be careful and don't jump to these results. Making students ineligible for a free lunch will improve their test scores. So don't interpret these variables, W variables, as causal. There is a concept of mean independence I have discussed in my video number 15 or 16. So in general, the corresponding is a causal effect. So this is not a causal effect. So be careful. So therefore, what is the difference between variable of interest and a control variable? As I am mentioning, my video number 16 is probably mentioned that what is control variable. These are control variables and this is my variable of interest. What is difference between the variable of interest X and control variables? So what we have already discussed can be considered causal. This can be considered causal when it is independent of U. But why we need to include W? If it is not included, then W is omitted variable. Then W is basically linked with U, and W is linked with U and X, and W are linked. So therefore, if you do not include W in your data, then X will not be exogenous. So that's why we need to include W, but W may not have itself a causal interpretation. So conditional mean independence concept, read it from chapter 13 as well as chapter 7 from Stock and Watson. So I'm not going to comment on this to make, otherwise it will be a very long video. So you can see this theory, conditional mean independence, I have already discussed in my video number 16. Thank you for watching. My next video will be generating these tables using stata and using R, and then we'll discuss regression discontinuity designs. Thank you for watching. Take care.